Okay, so in today's lecture, the first part of the lecture is the what are the possible ways for the redox reactions, and then we will discuss the factors which are making the spontaneous reaction to the non-spontaneous reaction. So this is very important because as a chemist you must understand what are the controlling factors for the vice versa conversion from the spontaneous to the non-spontaneous and for the non-spontaneous to the spontaneous reactions. So first I am going to explain the what are the possible ways, and this is the actually today lecture, half of the lecture I am discussing the very basic information, and it is up to you. You must carry on this information because without this knowledge it would be very difficult to understand the next content which we will discuss today and the next lectures. So here I'm starting with the very basic information, and you are actually working on these two half cells and studying these two half cell right from the intermediate. This is the reduction of the copper, and this is the reduction of the zinc. And here I'm asking that what are the possible ways for these half cells? These are the half cells, and because these are not the reaction, these are the half cell because it is only the copper. Copper it is going to reduce to the copper metal, having the zero oxidation state. This is the oxidation form. This is the reduction form. In a similar way, this is the oxidation form. This is the reduction form. So the first is to describe the possible ways for this reaction and for these half cell to react to each other, and what are the possible ways. And here let's suppose I'm going to explain. Can any one of you which one of the copper plus 2, that means copper plus 2, or the copper or the zinc plus 2, or the zinc is going to react with one of the metal ions or the metal in at the zero oxidation state? Let's suppose if I am going to reduce copper plus 2, then what are the possible ways for this copper plus 2 to react with the either? It is possible if this copper plus 2 is going to react with the copper, or copper is going to react with the zinc plus 2, or the copper plus 2 will react with the zinc metals. So first I am going to just to explain what are the possible ways, and the possible ways over here. So again, these are the so how these are going to connect. Let me share with the whiteboard. It would be easier for me. So that is this is the, let's suppose this is the copper, and oxidation state is plus 2, receiving 2 electrons and converted into the uh, copper having the zero oxidation state. And then there is another half cell. This is the zinc plus 2 plus 2 electron, and this zinc is going to reduce to the zinc also with the zero oxidation state. So here I am going to ask what are the possible ways. Let's suppose I'm drawing the number of possible ways. Let's suppose this is the one way. If the copper plus 2 may react, I am using the word may react with the zinc plus 2, and actually this you have to decide later on in this lecture. And this is the maybe the second option, this was the first option, and this may be the third option, and this may be the fourth option. These are the four possible options I stated. This is the number one, this may be the number two, and this is the number three, and this is the number 4. So maximum there are 4 options are there in which these two half cell can react to each other. And now you are going to decide actually which are the actually the spontaneous and which are the non-spontaneous, and even which are actually not possible for this for these half cell to react to each other. So the first, one by one, in a similar way, I'm not discussing only this one example, and in a similar way, you can decide the possible way with any of the two half cells, and which you can take from any book or the table from the Google as well. So I am writing here the first possible way. That mean I have written this. That mean the line is showing that these are the reactant. If these are the reactant, of course, these will be the product. So there are only the four reactant, four options are there. If I'm connecting these two as a reactant, of course, they will reduce to the zinc and the copper. So I'm just starting over here. Let's suppose this is the copper plus 2, option 1 is going to react with the zinc plus 2, and it is forming copper metal and the zinc metal. So this is the first option, and the second option is the maybe the this is the this one. That means opposite to the this reaction, when copper metal plus zinc metal, because I'm not feeling convenient with writing with the mouse, so better to write your own notes. So whatever I am speaking, important is the point which I'm going to describe, and maybe there is misunderstanding while writing the symbols of these metal lines of the metal. So when these two are going to react, copper is going to react with the zinc, and then what would be the product? Of course, this will be the product. There is no other option available over here. So this would be the copper plus 2 and plus zinc plus 2. So look at the first one. Actually, the first one and the second one, these are opposite to each other here. These are the reactant and these are the product. And in the second option, these are the reactant and these are the product. So let's finish deciding the possible reactivity of these metal ions to each other. And could you, any one of you can give the idea either the first reaction is possible in nature, or the copper plus 2 may react with zinc plus 2 to form the copper and the zinc. Any comment from you?
सर ये इम्पॉसिबल है क्योंकि इनके पास
पहले वाला सर
इलेक्ट्रॉन ही नहीं है।
इम्पॉसिबल है।
चलिए एक करके बताएं. So the first is answering is the Fakhr. So first is the you say it is the impossible. What is the reason?
सर इनके पास इलेक्ट्रॉन ही नहीं है सर, जो अपने वो शेल कंप्लीट कर रहे हैं।
चलें. Any
सर वो रिड्यूस हो रहे हैं, उनके पास इलेक्ट्रॉन ही नहीं।
चलें. From any other comment, please. Amna Sahar, what do you suggest? Either the first reaction is possible or not. If not,
No, no, sir.
what is the
First
reason?
reaction, sir, electrons ना होने की वजह से,
इलेक्ट्रॉन कहाँ पे नहीं है?
मतलब कॉपर प्लस 2 और जिंक प्लस 2 में सर।
तो इलेक्ट्रॉन कहाँ पे नहीं है? Where are not the electrons? Okay. Asra Shahid. So please give the answer quickly, so I will move to the next.
First is not possible, or
Why it is not possible? That is the reason I am going.
सर उसमें दोनों ही ऑक्सीडाइज्ड फॉर्म में है।
Perfectly.
इसमें होता है
Okay, that is the
एक
correct.
ऑक्सीडाइज्ड में होना चाहिए और एक रिड्यूस्ड।
That is the answer. So the first is this reaction is not possible. Why it is not possible? Because the both are in the oxidized form, and these both requires the electrons as mentioned over here. If the copper will receive two electrons, then it is converted into the copper metal. And in a similar way, if there are two electrons, if the zinc is getting two electrons, then it जी बच्चे बताएं. So, in a similar way, if the zinc zinc receive two electrons, then it is converted into the zinc metal. That means both these oxidation states required four electrons, and in this reaction there is no source of the electrons. So that's why this reaction is not possible. This will never happen in nature. Even you put the two salts together and keep it for years, this reaction it will not going to happen, because the both needs the electrons, and there are the four electrons are required, and there is no source of donating the electron to these metals. That's why this reaction is not possible. And in a similar way, you have to explain whenever I ask in your examination. So this is the second option, which is written over here. If these are the reactant, of course, these will be the product. So is the second option is possible? So I'm going to
No,
ask
sir.
the, okay, this is the Nurul and Khalid. What is your, is it the second option is possible or not possible, and what is the reason? Unmute yourself, please, and then ask, answer the
Sir, I
question.
think so. Second reaction is possible, but there will be addition of electrons will be loose in this
Okay.
reaction.
Okay. Sayyida Maryam. Sayyida Maryam. Malik Babar Ali.
Sir, I think second is not impossible. Zinc is oxidized form. In another case, copper will be reduced. So both are oxidized in that case.
Okay. Perfectly. In a similar way, I have described before, the second option is also not possible. And what is the reason? Because both are in the reduced form, both are going to oxidize, and again there is no source for the uh, which are giving them the force to oxidize. So simultaneously two metals in the zero oxidation state cannot be oxidized in a similar way, which we have explained in the first option. So whenever you find the both oxidation state or the both reduction state in any of the two half cells, these two options are not possible. So moving to the third option, third is the when copper is going to react with the zinc plus 2. So I'm writing the again the copper. There are two options: copper plus 2 plus 2 sorry, this is the copper is going to react with the zinc with the zero oxidation state, and this is going to form the copper in the zero oxidation state plus zinc with the plus 2 state. And the next option will be the reverse of this one, when these are the reactants. That means copper plus zinc plus 2 is forming the copper plus 2, and zinc is going to reduce with the zinc zero oxidation state. So these were the first, this is the copper plus 2 with the zinc metal, and see copper plus 2, This is the copper plus 2 with the zinc metal. Actually, this was the our 4 option, and this was our the third option. So I am writing over here. This was our 4 option, and this is the third option. It is just the number, it doesn't matter what I'm going to describe over here. So let me again focus on this one. Either which either the this one option is possible in nature or not. So any one of you can comment on this one. Either
पॉसिबल है सर, ये
It is
इसमें रिडक्शन
possible.
और ऑक्सीडेशन दोनों हो रही है.
दोनों ही हो रहे हैं.
possible है.
Sir, it's possible.
Sir, both are possible, sir.
okay, this maybe I am using the word maybe. So concentrate on the words which I am going to use over here. You said this may be possible, but we will focus later on what it does it mean. And this also may be possible. Okay. And what is the reason? The reason is here. One is going to reduce. This is the reduction. And of course, this is the oxidation. Oxidation, it is going to give 2 electrons, which is taken up by the copper. It is converted into the copper metal perfectly. This should be the redox reaction. It should be like this. And if you look at this one, and this is the reduction, and this is the oxidation, and this is also a redox reaction. That means the in this case zinc plus 2 is reduced, and when the copper is oxidized to the copper plus 2, that means 2 electrons are released in this case, which are taken up by the zinc to reduce to the zinc metal. So the fundamental principle over here is both in these two half cells, one is the oxidized form, other one is the reduced form. Here the copper is the reduced form and the zinc is the oxidized form. So both one is the oxidation and the other one is the reduction is happening over here. That's why these reaction may be the possible reaction. This may happen. Now our target is we have defined there are the 4 possible way, 2 are impossible. You cannot consider in chemistry, they are not going to happen. That is okay. Now there are the other 2 options in which in both options there is the oxidation and reduction. So as a chemist, now you have to understand which one is the spontaneous way and which one is the non-spontaneous way. And later on I am going to connect this lecture with the rest of the topic if you understand this concept. So any one of you can give the idea which one half cell is the spontaneous. This may be, but this may we are now going to consider the spontaneous or the non-spontaneous. So which one is the spontaneous and which one is the
The
non-spontaneous?
one in which copper is reduced is spontaneous one.
Okay.
Fourth one.
Fourth one, this was the fourth.
Yes, sir.
Okay. So fourth one is the spontaneous, third one is
Yes,
the
sir.
non-spontaneous. What is the
Non-spontaneous.
reason? Why it is
So
you are saying?
because,
Okay.
sir,
Good.
it is because of the reduction potential, as copper has more ability to reduce,
Okay.
hence it will not oxidize and will have the preference to reduce itself. That's why it is a spontaneous process. And in order to oxidize copper, we need to give it an external potential.
Okay, very good. So these are the actually the reason behind this one. And again, if I ask for those students who still are unable to understand, actually we have already in the previous lecture we discussed this is the the cell potential. It is the equal to the half cell of the cathode minus half cell of the anode. So you have to calculate the cell potential. So spontaneous mean if this is the positive, then it should be a spontaneous. And if it is the negative, then it should be a non-spontaneous. So this is the way you can describe with the reason. Of course, in both cases, the potential is involved, but because I am starting with the very basic, and then I will, of course, I will give any of the reaction, and in this way, you have to explain what is the spontaneity of the reaction. And if you understand this spontaneity, then we will convert we will discuss the factor how to convert this spontaneous to the non-spontaneous reaction. And this is very important as a chemistry and very interesting to know that how you are going to make such type of the reactions. So here, okay, so okay, so again, in the first, now I'm with, if you want to spontaneity of the reaction, you must have a cell potential. Without cell potential, you cannot say which one reaction is the spontaneous or the non-spontaneous. So I am going to write the cell potential over here. This is the potential of this one is the 0.34, and this one is the minus 0.76. So now you can calculate the cell potential. Let's suppose for this cell, and look at copper is going to reduce. That means reduction in this, in case of the copper, that means reduction will always be happened at the cathode. So you must remember, if there is the reduction of the metal, then it must be at the cathode. And if it is oxidation, oxidation must happen at the anode. And with the vowel words you can remember, because here oxidation is also a vowel word, anode is starting with the vowel words. So must remember, oxidation will always take place at the anode. So this is easier to remember, this one. And simultaneously reduction will always take place at the cathode. Either this, the cell is the spontaneous or the non-spontaneous, doesn't matter. These are the fundamental established facts. So if I want to calculate the cell potential for this half cell, so it would be the E cell, that is equal to cathode. Cathode potential is the copper, in this case 0.34, and you can say this is the 0.34, and let me start with the other. So point E cell would be the equal to the 0.34. This is the reduction, E cathode, and I said this is the minus E anode. So minus is for the formula just to reverse the sign of the anode. So must remember, you do not need to reverse the sign two times. So this minus sign is actually to reverse the sign of the anode. And what is the potential of the anode? In this case is the minus 0.76. So this is, I have written over here, this is the minus 0.76. So this is the potential. So you must keep the sign whatever it is written over here. And if it is the oxidation, of course this will become the positive. If it is the positive, this will become negative in case of the oxidation. And again, this minus sign is already there to reverse the sign. So you are not, you will not reverse the sign first with the half cell, and then again the sign to put over here, then automatically you will do the wrong calculation. So here 0.34, and this is the minus multiplied by minus is the plus 0.76, and your answer will be the 1.1. So this would be the in positive. That's why the reaction, this, the fourth option is the spontaneous reaction. So you can say this is the spontaneous. This is the one of the possible way, but this possible way is the spontaneous reaction. That means it will automatically occur when you put up the zinc into the copper ions. So there will be the start of the oxidation and the reduction of these two metal ions. So in the other case, for the option number 3, again you can calculate the cell potential, and the cell potential in this case will be, because here now we are going to consider this is the reduction, and the reduction, as said, this must be at the cathode, and oxidation must be at the anode. So in this case, zinc is reducing and the copper is going to oxidize. That means zinc is at cathode and copper is at anode. Again, you do not need to change the potentials of the half cell. These will remain the same. So here just cathode will be the minus 0.76 minus, and anode is the minus 0.34, and the value will be same with the minus sign. That means this is the non-spontaneous reaction. So this is the way how can you explain the spontaneity as we had discussed in the previous class, but here we have calculated the half cells. And scientifically you cannot judge the just by looking the half cells only. So this is the potential of the half cell. You have to calculate the potential. If it is the positive, you can say this is the spontaneous, and if it is in negative, then it would be a non-spontaneous. So the third option is the it should be a non-spontaneous reaction. That means this energy is required if you make this reaction a reversible reaction as compared to the this one reaction. So with this, actually I am going to end over here the first part of the today lecture. We have 1 minute. You have to re-log in again, and we will discuss the rest of the lecture. So please rejoin me, and first we discuss, and then I will start the lecture.